All right. So we proceed. So let's also look at the algebraic operations of complex numbers. So algebraic operations are just addition, subtraction, multiplication, and division. Yeah. So before we look at the operations, let's look at what equal complex numbers are. So equal complex numbers only exist. Uh, let's say, for instance, you have Z1. Let's name this Z1. And okay, yeah, since there's W here, there's no need of us renaming that. Okay. So when you have Z being equal to X plus Y, I1, and W being equal to U plus IV. So if these two complex numbers are equal, it means that the real part for Z is equal to the real part for W. And then the imaginary part for Z is also equal to the imaginary part for W, which is B. So this is what we call, so when you have such things happening, note to say the complex numbers are equal. So let's proceed. So let's look at this example from the tutorial sheet, which says, find the values of A and B for which 2A plus 3I is equal to 6 minus IB. So on this complex number, we know to say the real part is A is 2A. So the real part here is equal to 2A. And then this side, on this complex number on the right hand side of the equal sign, we know to say the real part there is 6. So you put them like that. So from here, you can now find the value of A. You just divide by 2 on both sides, and then find the value of A being equal to 3. Same applies to the imaginary part. You take the imaginary part this side, which is 3, and then this other side, the imaginary part is going to be negative B. So when you divide by -1 this side, divide by -1 that side, you find your answer to be, the value of B to be -3. This is what it means by equal complex numbers. So let us proceed. Let's see what we have. Yeah, we start first by addition of complex numbers. So when you're adding two complex numbers, X, Z, and W, when you're adding these two complex numbers, maybe Z is X plus IY.
Mr. Teddy.
Yeah?
Mr. Teddy.
Yeah, I'm getting
So
you.
they specify in the question whether they are equal or not. You have to find out on your own.
Oh, for this question here.
Yes.
Okay. Here, what you should, if you want to know whether these two complex numbers are equal, sometimes they can tell you in the question, but if they've not told you, look at the operation here. This equal sign simply showing you to say these two complex numbers are equal. Hope you've gotten the concept there. Okay, you can proceed. Yeah, so this is what I was talking about when you have Z.
Yes, and isn't B isn't it supposed to be -3?
Yeah, it's -3. Oh, sorry, I didn't just put the negative here. All right, so thank you very much. I didn't, but when you divide 3 by -1, you get -3. Yeah, I didn't just put it there. All right, so let's continue. So you have X plus IY. Then maybe for W here you have U Oh, sorry for the inconvenience. I don't know what happened. I think the network just cut. So let's continue from where we ended. So this is what I was talking about. When you have these two complex numbers, W and Z. So when you're adding the two complex numbers, Z plus W, what you do is you just add the real part, you add it to the real part that side. So in short, what you're saying is you add X to U, and then you also add Y and V. But of course, for these imaginary parts, you always have to put I outside. So that's what we are talking about. So addition of complex numbers is just the normal you add all other numbers. You just collect the like terms and then add them. So what I'm just talking about here. You add the real part and the imaginary part. Same applies to subtraction. So when you're subtracting two complex numbers, you do the same. You subtract the imaginary parts and add and subtract the real parts as well. So it's, in short, it's just a matter of putting the like terms together. And then multiplication of complex numbers. So when you're multiplying two complex numbers, let me just explain something here. When you have, let's say, for instance, you have X plus IY, then you're multiplying it with maybe another X plus IY. Here, what you need to do is you multiply it you multiply them the way you multiply every other function, where you say X is multiplying with everything this side and Y is multiplying with everything that side. So you have your X plus IY this side, and then plus IY this side, and then you have your X plus IY. The normal way you multiply other complex numbers. So here, when you open the brackets, you find your answers to be X, you find X squared plus X, Y, I. Even here, IY times X, you get your answer to be X, Y, I. And then this side, when you are multiplying, this is where it's a little bit tricky. A lot of people get it wrong just here. When you multiply IY times IY, remember what we said, I times I will give you a negative. So meaning instead of getting positive Y squared, you get something like this. Okay, let me just write it the way it's going to be. So it's going to be I times I, there you get I squared, and then Y times Y, you get Y squared as well. So this is what you're going to have, X squared, and then XY plus XY there, you get your 2XY. Here there's a plus, you get your 2XY. Of course, don't forget to put your I there. And then this side, I squared, we know to say I squared is -1. So -1 times Y squared, you get your negative Y squared. So it's just a matter of multiplying it the way you multiply other complex numbers, but just take care of this I when you're multiplying it with another I. So we proceed. So this is what I'm talking about here. Just that here in the example, we used the U and V in X and Y, but otherwise everything is just the same. And then after simplifying everything, make sure that you put the real parts together. And then you put also the imaginary parts together. So proceed. Division of complex numbers. So when you're dividing complex numbers, it's just the same. There's no difference, except that when you're dividing, sometimes you may be required to use what we call a conjugate. A conjugate, if for instance you have x plus I, y. When you have x plus I, y, the conjugate of this is nothing but x minus iy. So you just change the sign here. That's the conjugate. Okay, let's continue. Yeah, so this is what I was talking about. When you have your z being equal to x plus iy, and then your w being equal to u plus iv, when you are dividing complex numbers, there's need of you in most cases to use what we call a conjugate. So a conjugate is it's just the same complex number of which is the denominator, but you just change the sign in between here. If it was plus here to be minus, and then what you do on the denominator, you also do the same on the numerator. Meaning if you're multiplying with u minus iv on the denominator, even the numerator you multiply it with the same, then you get this, and then you simplify them to that. Okay. I've seen a hand. Let me just see. All right. Okay, let's proceed. So let's look at this example here. Okay, so this is the first question in your tutorial sheet. It just simplifies all the operations of complex numbers. So on this question, you can see it to say the first question is straightforward here. It's just a matter of adding them. Where you say three, you add it with okay, let me write it here. So you're just getting the imaginary, I mean the real parts, you add them together, and then you also add the imaginary parts together. So what I'm trying to say is you add this 3 plus that -5. So you add 3 plus -5, and then you also get your -4i. You add it to +7i. So I'm trying to answer A. So when you add 3 plus -5, you get your -2 here as your answer. And then -4i plus 7i, you get your +3i. This is what you're going to get. So I'm just remaining with less than 10 minutes. Okay. So this is the first part. This is A. We also look at B. Oh, sorry, this is I. We also look at 2. 2 is just the same as I. Even 3 is multiplication. So let's do one multiplication and one division. Then we are done with this question. So I'll do the multiplication of this 3 here. Just want you to see where a lot of people make mistakes. So we're going to have 2 plus let me just do this. instead of copying the whole question, since the question is already there. So this 2 here is going to multiply with everything in these other brackets there. So what I mean is this, the 2 there multiplies with everything in these brackets, which is 3 minus 2 over 5 I, and then plus this I again multiplies with everything there, 3 minus 2 over 5 I, like that. So here we begin to expand now. 2 times 3, you get your 6. 2 times negative 2 over 5, you get your negative 4 over 5. So you get your negative 4 over 5 I. And then you multiply here positive I times 3, you get your positive 3I. And then positive I times negative 2 over 5I, we're going to have negative 2 over 5I squared. So here what you do, you simplify, this is 6, and then when you add this can also be written as 1 over 1. So when you add this to be negative 4 plus 3, you get negative 4 plus 3, you get negative 1. And then everything over the common denominator, which is 5. Oh, sorry, not that. Negative 4 plus 15, you get negative 11. Negative 4 plus 15, you get negative 11. Sorry, it's going to be positive since the biggest number is the one that is positive there. So you get positive 11I over 5. And then this side, we know to say I squared is a negative number. Negative 1 times negative 2 over 5, you get positive 2 over 5. So here again, it's just a matter of putting the real parts together. So the real parts that we have is 6 plus 2 over 5. And then the imaginary part here, we only have 11 over 5. So we add this. This is the same as 30 plus 2, which is 32 over 5. And then plus 11 over, this one is supposed to have y. Oh, sorry, I. 11 over 5i. So these are the solutions. This is the solution when you're multiplying. Then let's also take one division. So I'll take the simple one, and then for these ones which look complicated, you can solve it on your own and then try to send the solutions I check. Then I'll tell you why you went wrong. So due to time, let me just take any simple one, like, okay, even this one here. Let me just take this one. So that one is saying 2 minus 3i over 3 minus 2i. So here, the conjugate of the denominator is, we just change the sign there. So we're going to have 3 plus 2i. And then on top, you also multiply with the same thing that we multiplied the denominator with, which is 3 plus 2i, like that. So here, when you multiply, we are going to get something like this. On the numerator, we are going to have 6, 2 times 3, 6, 2 times 2i, you get plus 4i, and then 4i minus 3, minus 9i, 4i minus 9i, you are going to get your negative 5i, and then negative 3i times 2i, you get negative 6, but I times I, you get a negative number. So negative 1 times negative 6, you get a positive 6. like that, and then everything divided by. So these conjugates is the difference. It's always the conjugates are always the difference of two squares. So instead of you multiplying them the way I've done with the numerator, you can just say 3 squared minus 2i in brackets like that, and then squared. And then what you're going to get here is when you simplify this, you're going to have 6 plus 6, you get 12, and then minus 5i. And then here the denominator, you get something like, this is 3 to the power 2 is 9, and then minus 2i squared, you get 4, and then I squared will be negative 1. So this times that, negative 4 times negative 1, you get your answer to be a positive 4. So here you're going to have plus 4 like that. So we simplify it now. We're going to have 12 minus 5i, and then everything divided by 9 plus 4. So 9 plus 4 is 13. Then since they want us to leave it in this form, they want us to leave it in that form. So we can just split this to be 12 over 13 minus 5 over 13. I this side. So this is your answer. That's your answer for, yeah, for division. We're trying to get n of these on division. So this is how you solve this is how you simplify complex numbers. They're just as simple as this. Then you have also another example, which is that. So these examples are also just the same. They are telling you to say, find the real part of z. They're saying find the real part of z. RE, we said, is just the same as the real part of z and the imaginary part of z. So for instance, if these questions were the ones on which we were asked to find the real part of z and the imaginary part of z. So it's after simplifying this expression. When you simplify this expression, this is going to be your real part, and then this is going to be your imaginary part. So in other words, what they are saying is just simplify. They're just telling you to simplify this. Let it be in the form x plus iy. Yeah, let it just be in the form z is equal to x plus iy. And then the value here that we're going to get is the one that you just say, therefore the real part of z is equal to x. So the answer that you get here after simplifying, you put it like that. And then the imaginary part